when you read this question, you might say, hey, haven't we done one like this before? And the answer is yes. When we did this exact same question last time, the only difference was instead of this, it said negative 360 degrees less than theta less than 360 degrees. So the idea stays the same, but we just need to do it in radians now. So how do we do this? Well, it was a triangle question when we did it last. We drew all our quadrants and said, well, where is negative 4 comma 3? That's this point right here. So if that point is on the terminal arm of an angle in standard position, this is a possibility for our angle in standard position. We could also have the angle here as a negative angle in standard position. 360. And since we're looking from negative 2 pi to 2 pi, again, we're going to think starting at 0, that would be positive angles once around. From 0 to 2 pi is once around in the positive direction. And from 0 to negative 2 pi is once around in the negative direction. So those are our two answers, the green one and the red one. In order to figure those out, just like we did in degrees, what we need to do is find this reference angle. And we find that reference angle by making a triangle and saying, what do I know about that triangle? I know this length is 4, this length is 3. Maybe you recognize this triangle and can say right away that the hypotenuse is 5. That's fine, but you wouldn't even need to know that, because if I want to find my reference angle, and I knew the opposite side was 3 of this triangle, and the adjacent side was 4, I can say that tan of my reference angle is equal to 3 over 4. That's just using grade 10 trigonometry and knowing that your tan is your opposite side over your adjacent side. And then from here, we can use our calculator by doing the inverse of 3 over 4. The main difference now is instead of having our calculator in degrees, now our calculator's in radians. So when we do tan inverse of 3 divided by 4, we get 0.644, the nearest hundredth. What does it ask us to go to the nearest tenth? So our reference angle is 0.64. And we got that from our calculator. Now, if I was finding the green angle in degrees, does it make sense that you would do 180 degrees and minus your reference angle? Now we're thinking in radians. Instead of doing 180 degrees minus my reference angle, I'm going to do pi minus my reference angle. And so when I calculate my green one, again, I'm going to need to go to my calculator. And one of the things that I'm going to do in my calculator, and depending on which calculator you have some different options. I'm going to need to use that reference angle more than once. So above your on button is a store button. I'm going to store my answer as x. And it just temporarily stores it as x. And that's nice because now I can go pi minus x instead of having to retype that. Now, some of you might have used the answer button, which also works really nice in this case, but I know that I'm going to want to use it more than once, so I like using the store button. So my green angle is 2.498, which to the nearest tenth is 2.5. My red angle, again, if I was looking at this in degrees, I would have done 180 plus my reference angle and then made my angle negative. So I'm going to do the same thing here. I'm going to make my angle's going to be negative, but I'm going to go pi plus my reference angle to figure out what that angle is and make it negative. So again, I'm going to go to my calculator, and this is where it's nice that I stored my answer as x. It still remembers that, and I get 3.8. So my angle here will be negative 3.8. So drawing the picture helps us see our answers, and then we figure out our reference angle and do everything the same as we would in degrees, but now we're using radians. So instead of 180, we're using pi. And we're still using our reference angle to calculate things. Part B, given cotangent equals negative 2, determine all the values of theta in the domain. Sorry. So if cotangent of theta equals negative 2, that means that tangent of theta is negative 1 over 2. So when dealing with reciprocal functions, we can take the ratio or the answer and do the reciprocal of that. Now, if tangent is equal to negative 1 over 2, that tells us that tangent is either in quadrant 2 or tangent is in quadrant 4. Because according to the cast rule, if tangent is negative, it's going to be in quadrants 2 or 4. So I can draw a triangle back to my nearest x-axis for both of these, label my reference angle on both of them, and then because tan is 1 over 2, that means the opposite side over the adjacent side is 1 over 2. Notice I'm labeling lengths of sides of that triangle. I'm not worried about positives and negatives when I'm labeling them. And then what I need to do is I need to find my reference angle. So my reference angle, again, this is just grade 10 trigonometry. You use the positive values because we're actually thinking about that triangle with positive lengths. Calculate your reference angle with tan inverse of positive 1 over 2. Again, our calculator is still in radians, so we go tan inverse of 1 divided by 2. And we get 0.46 as our reference angle. Does it say to the nearest tenth again? So to the nearest tenth, that would be 0.5. What's the domain that we're trying to find? The domain in this question is from negative 2 pi to 2 pi. So that means once around in the positive direction from 0 to 2 pi, and once around in the negative direction from 0 to negative 2 pi. So I'm going to do the positive ones in green. One positive answer will be this one in standard position. Another positive answer would be this angle in standard position. And our negative angles, I'll do in red. In standard position, this would be one negative answer, and this would be our other negative answer. So thinking about each of these arrows and what the angle would be, I'd find my first positive one by going in degrees. I would go 180 minus my reference angle. So now in radians, that green arrow would be pi minus my reference angle. For the second green one, in degrees I would do 360 minus my reference angle. So in radians, I would do 2 pi minus my reference angle. So let's write out our positive ones right now. Go back to our calculator. Again, I'm going to store this answer as x so that we can use all the decimal places. Even though we've rounded, you use all your decimal places until your final calculations. So in quadrant 2, it would be pi minus our reference angle, which I've stored as x, 2.7 And in quadrant 4, I would go 2 pi minus my reference angle, which I've stored as x, and I get 5.8. For my red angles, in quadrant 4, it's just going to be my reference angle negative. So that one we don't even have to put into our calculator. It's just going to be negative 0.5, the same as our reference angle. For quadrant 2, if I was doing this in degrees, I would do 180 plus my reference angle. In radians, I would go pi plus my reference angle, and whatever answer I get, I'll make it negative. So I'll go to my calculator, pi plus x, 3.6. So I get negative 3.6. Questions for practice are 13 and 14. So we get 4 answers, 2 in the positive direction and 2 in the negative direction.